Hello everyone. This is homework number 10, the rectangular or Cartesian coordinate system. And we use the term Cartesian with reference to Rene Descartes. He was a famous mathematician and philosopher from the late 1600s, early 1700s. And we call it the coordinate system, so rectangular, Cartesian, often referred to also as the plane. It's basically just an intersection of two number lines in a perpendicular fashion, and it is two-dimensional. So we have an x-axis, which is horizontal. So let's just make a sketch of the plane to get a feel for what it looks like. So this is an x-axis, and we typically will label it as x, off to the right. We have a starting point of 0, of course, but I'm not going to label that. I'm going to label the 1, it's just a number line, so 1, 2, 3 to the right of 0, -1, -2, -3 to the left of 0. But then we have the y-axis that intersects perpendicularly at 0. So the y-axis comes in and slices it right at 0. And then the y-axis also is a number line. Now we should label it with y, typically in the upper portion, and positive. For x, positives to the right and negative to the left as normal. For y, positive is up, 1, 2, 3, and so on, and negative is down. So -1, -2, -3, and so on in that direction. And then we define the origin, and the origin is where the two axes intersect. So there I've actually marked it as a point, and we'll define that momentarily, but that's the origin. And we used Roman numerals for the quadrants, because when we separate a plane into this Cartesian or rectangular coordinate system, it creates 4 regions. And the region to the upper right we label as quadrant number 1, and we use Roman numerals to indicate the quadrants. And so then counterclockwise, so the next region is to the left of that, that's quadrant 2, quadrant 3 to the lower left, and quadrant 4 to the lower right. So those are the quadrants. Now we define a point in the plane as an ordered pair of real numbers, and we'll see momentarily that order does make a difference. The notation has to be used where we enclose the x value and the y value separated by comma in parentheses, and the x value is considered the x coordinate. There's a formal name for that as well. We call it the abscissa, but nothing to worry about there. And the y value is the y coordinate. And we have a formal name for that. That's called the ordinate. But again, just knowing that they're called x and y coordinates is going to be sufficient. So what we want to do is be able to plot any ordered pair, and also state on which quadrant, in which quadrant it lies, or maybe it lies on an axis and not directly in a quadrant. So here's a pre-made grid. This graph paper is available in Blackboard, so it's kind of nice because it's already labeled for us. We should always label the axes, so x and y. And this point A given by 5 and 2, that means from the origin. Okay, well, the origin, now that we define the point, the origin has coordinates of 0, 0. So we're 0 in the x and 0 in the y. So that's where they meet. And we always start from the origin to plot a point. And we have to move both in the x and y direction. So you move in this case, if we're plotting A, which is given by the coordinates 5 and 2. From the origin, we move 5 in the x and 2 in the y, and that would be point A. And now we can see that that lies in quadrant 1. And we just use Q for quadrant, and then we indicate the Roman numeral of what quadrant it represents. And so going to point B, now notice that all I did here was switch the order, right? Instead of 5, 2, it's 2, 5. So that's why order makes a difference, because now this says go in the x direction 2 units, and then in the y direction 5 units. So again, always starting at the origin, from the x 2 units, but that's not the point. We have to complete the ordered pair by moving 5 units in the y direction. So that would be up to here, and that would be the point B. And we can see that also lies in quadrant 1. Okay, so the point negative 3, 4, from the origin, negative 3 in the x, positive 4 in the y. So origin, negative 3 in the x, positive 4 in the y, it looks like right there. So that's going to be point C. And as we can see, that's in quadrant 2. So if you want to label the quadrants, once again, quadrant 1 upper right, then counterclockwise, quadrant 2, quadrant 3, and quadrant 4. Okay, 3, 0. So in the x 3 units, but in the y 0 units. So we're actually on the x-axis, and that's the point D. So here we're not in a particular quadrant. The point lies on the x-axis. And something to note there is that any point that lies on the x-axis will have a y-coordinate of 0, because you're not moving in the y direction, you're just moving in the x direction. That's something that's going to be important to note, and will come in very handy later on. Similarly, if the x coordinate is 0, okay, let's plot this first. So 0 in the x means we're not moving horizontally at all. Negative 8 in the y, so down 8 units. Right there, that would be the point E. And notice how that lies on the y-axis. And so, similarly as to point D, although it's the opposite situation, the x-coordinate is now 0, and so the point lies on the y-axis. So it's almost like it's opposite. If y is 0, it's on the x-axis, and if x is 0, it's on the y-axis. In any event, moving to point F, 4, negative 5. So in the x direction 4, y direction negative 5, so right here. And that would be point F. And that looks like it's in quadrant 4. Negative 6, negative 5, so in the x direction, always start at the origin again, negative 6, down 5, looks like right there, be the point G, and that we can see is in quadrant 3, and then finally negative 7 and 0. So you know it's one of those special points that lies on the axes, right? Which one is it? Looks like the x, because you're moving negative 7 in the x direction, 0 in the y direction, and that, well, I guess I should have labeled that as point H. Let's change that. Call that point H. Okay, so that's how we plot points, so you have to be proficient at doing that. Also, you should be able to state the ordered pair given a point. So I have a blank grid here. I'll just pick some points. Let's say this point here. I'll call that A. All right, so what are the coordinates? We'll just read them. What does it take to get there? Now make sure you use a left parenthesis. List the x value, so we're moving 8 units in the x direction, and separate that by the y value, and we're moving 2 units in the y. So that would be the coordinates of point A. Let's go, how about this point? So that point, which we're going to call point B, we're going to move, we aren't moving in the x, so that's 0 in the x. So again, left parenthesis, x value 0, and y value 6. And again, notice when it's 0, one of the coordinates, it's on one of the axes. That is on the y-axis because x is 0. Remember, I just said it's like it's opposite. Okay, let me jump over here. Let's do this one. All right, I'll call that point C. So we're moving to get there. We start from the origin. Looks like we got to move 10 units in the x direction. So our parentheses, 10. How many units in the y? Looks like -5. Close the ordered pair. Let's jump over here for point D. Again, I'm just arbitrarily picking these points. Okay, so from the origin, first off, start with the parenthesis, right? And then from the origin, -8 in the x. Always x first, that's what we call the ordered pair. And it looks like -4 in the y. And close up the ordered pair. Let's go right here. Okay, now we're on, oh, look at this, I forgot to label the axes. Should have labeled the axes, x and y. Okay, so now in the x direction, -6. So I'm going to call that point E. So in the x direction, -6. And in the y direction, we aren't moving vertically at all. That's 0. And then finally, let's do one more. How about right here? Yeah, I'm going to call that point F. Okay, so from the origin to get to that point, move -4 in the x. So left parenthesis, -4, comma, y value, +8, and close the parentheses. Okay, so we have to be proficient at both plotting points and identifying the points. Oops, looks like I forgot letter H. I got so excited. That's on the x-axis. I forgot to fill that in here. May have said it. But I forgot to fill it in. Okay, so the next page. So when we solve a linear equation like we did in the last unit test, there was typically one solution. I know we had special cases where there was either no solution or an infinite number of solutions, but typically we had one solution. And we called that a linear equation in one variable. For example, if x plus 4 equals 9, we say that the solution is x equals 5. Obviously, because 5 plus 4 equals 9, we could do the algebra if we need to, but that can be essentially solved by inspection. But there's one solution. The value of x that equals 5 satisfies that equation in one variable. Now in equations, so now we define an equation in two variables. An equation in two variables will have both an x and a y involved. And a, b, and c are just numbers, but we have a stipulation here that a and b are both not equal to 0. Because if they were both 0, then there wouldn't even be an equation involving a variable. And a solution is actually a set of ordered pairs. So a value of x and a value of y that satisfy the equation. So I chose a very simple equation here to look at, and I have the Cartesian system off to the right. We're going to look at that momentarily. So x and y. Label your axes, of course. And I just said that some solutions are, and let's just guess what's going to work. Pick a value of x, and then what's going to work for y. So this is where sometimes students think that they kind of freeze because they don't know what to do. You're in charge. You determine what you want to choose for x. So let's just simply say that we're going to let x equal, you know what a good choice for x is at all times? 0. If x is 0, then we could say, if we substitute into the equation, so this is always the go-to equation, okay, we're going back to that, we'd have 0 plus y equals 5. So then that means that y is 5, which further means that we have the ordered pair, x is 0 and y is 5, that satisfies that equation. And so that is actually a point in the plane, right? And you could plot it. X is 0, y is 5, we're up here. So that's that point. Pick a different value of x. Let's say x is 2. All right, I'm just picking these numbers. I'm not, it's arbitrary. As we're going to see, you can pick any number you want. If I substitute into this equation, we have 2 plus y is 5. So then the value of y, corresponding y value must be 3. Because 2 plus 3 is 5. So therefore, the ordered pair is, when x is 2, the y value is 3. And I can plot that, 2 and 3. And so we could generate more if we want. Let x equal, let's say 4. Then into the equation 4 plus y is 5, and then we get that y is 1. So then we have the ordered pair 4 and 1, and we could plot that as well. And we can continue to do this, pick any value of x that we want, and generate the corresponding y values, and generate an infinite number of solutions. Okay? And if we plot these solutions as we've plotted those points, the graph that we get is a straight line. So you could see that these 3 points all line up neatly, and if you found more, they would line up neatly as well. They all line up very neatly, and there will be the graph of this straight line. And typically when we do graph a straight line, you won't have to do this in my math lab, but if you're doing it by hand, you typically will write the equation next to the line. Okay? But you can see that any point on this line satisfies that equation. For example, right here, this is the point where x is 5 and y is 0. And when x is 5 and y is 0, that satisfies the equation as well. Okay, so that's pretty much what we're going to be doing for the next 2 units, or 2 lessons, homework lessons. We're just going to be finding these ordered pairs that satisfy the equation. And there's little tricks involved, as we'll see. But for example, here, it says complete the table. Now here they're giving us the values to use. So we're going to literally just replace the given value and find the corresponding either x value or y value. There's really three parts to this question. This is part A, this is part B, and this is part C. So for part A, I'm going to say it this way. You don't have to write all of this out, but this is showing it formally. When x is 0, and you can do as much of this mentally as you want. Okay, this is the go-to equation in this case. We're given that y is negative 6x. When x is 0, y is negative 6, and we're replacing x by 0, so substituting, we'll put parentheses or the multiplication symbol, because it's understood between the negative 6 and the 0 that it is multiplication. And so when x is 0, y is negative 6 times 0, or 0. So we could fill in that part of the table. 0, 0 would be a point, and we could plot that if we want to. Right now we're just going to look at filling in the table, and then later on we'll worry about plotting and making the graph. But that's pretty much all there is to the next 2 units. But as I said, there are little tricks involved. Some subtle points. No pun intended. Okay, when x is negative 1, okay, so that's part B. Y is, all we're doing is substituting. Go to equation, negative 6x, negative 6, in parentheses, negative 1. That gives us positive 6. So negative 1 6s in ordered pair. And now it's telling us in part C what happens when y equals 5. Okay, so make sure you read the table correctly, and now it's telling us the y value is 5. It wants to know the x value. So now in the equation we have 5 equals negative 6x. So now we have to solve for x, and we do so of course by division. So we're going to divide by negative 6. And let me just move it over here. So we get negative 5 over 6 is equal to x. Okay, so you could get fractions. But see, we really don't want fractions. I mean, it's okay to have fractions. But imagine trying to plot negative 5/6, right, for the x value. It's not going to be very accurate when you go to your little Cartesian system, or a little grid there. Okay, in the next question, given the equation x equals negative y plus 4, given a bunch of values. This is an interesting thing. When first start off, again it's 3 parts, A, B, and C if you like. First off, we're going to let x equal 0. When you're letting one of these things equal 0, you really don't, well, you want to show the substitution, of course. So x we replace by 0, and just recopy everything else, negative y plus 4. And then we have to solve algebraically, so a lot of times we'll have to manipulate the equation. I'm going to add y to both sides of the equation to get that y equals 4. So when x is 0, y is 4. Okay, in part B, now we're saying y is going to be 0. So if y is 0, we have x equals, there's really no need to substitute a 0 in there, because that term disappears. So immediately, I mean, you could say minus 1 times 0 or minus 0 as I've written, but immediately we get x equals 4. Now we could have told that by inspection, because if y is 0, basically all you're doing in this equation is eliminating this y, right? And if you're taking out the y, obviously x equals 4. Okay? All right, so let's see what happens in part C. When x equals -6, then we get -6 equals minus y plus 4. Okay, if we subtract 4 from both sides to solve for y, we get -10 equals -y. And let me bring it up here. But now I've got to get y, not -y. And there's a 1 in front of that. It's a -1. So you could either think of multiplying or dividing by -1. I'm going to think of dividing by -1. And so we get that y is 10. Okay, so if we plotted those points, we'd realize that they line up in a straight line. Okay? All right, I think I'm going to stop there for this part. We'll come back and we'll do the remainder of this lesson. And so we'll make it a part 2 for homework 10 when you're ready.